So today we're going to be looking at 2.7 composition of functions. So the composition of functions is when one function is plugged into another function. So it's an operation that we can do. And the composition of functions is written in this form, where we have f of g of x or f of g of x. So we can either use that little open circle that we have there, or we can use parentheses. I personally like using the parentheses better, but we want to be able to know that they mean the same thing because they will be used interchangeably either by the book, by College Board, or by me. But I do prefer using the parentheses better. Now this is read as f of g of x. This is not a multiplication problem. The composition does not equal multiplication. So that little open circle does not mean times. If it's a dot, then that's multiplication. But the open circle means a composition. Now to help illustrate this a little bit better, you don't have to write this. I'm just going to kind of put some things up here. So if I had a function, let's say f of x equals 3x minus 5. Why not? Let's see. Jacob, can you give me a number? Any number, doesn't matter. 3, okay. What does this mean, ladies and gentlemen? F of 3. We know that, right? We take the 3, we plug it in, right? That would be 3 times 3 minus 5. I'm going to write another function up here. What if we had a function f of x equals, let's say, x squared minus 2. Why not? So if f of 2 means we just plug in 2, then what is f of g of x? We just plug in g. That's all it means. Just like in f of 3, we take whatever's in here and plug it in, we do the same thing. We take whatever is our function g and I plug it in. Now, a lot of times I will write it like this. I say, okay, what is g of x? Well, that's x squared minus 2. But again, all that means is x squared minus 2 gets plugged into f. And where do we plug it in? Wherever we see x. So that would just be 3 times x squared minus 2, minus 5. Okay? Can we see that this process is very similar? Whether we're doing just f of 3 versus f of g, it means the same thing. We're just taking whatever that is and we're plugging it in. Now, what if I reverse that? What if instead I did g of f? What does that mean now? So whatever f is now gets plugged into g, right? If we change it, we change what gets plugged in and plugged in where. So that would be g of 3x minus 5. And all of that now gets plugged into g. So g is x squared, so that would be 3x minus 5 squared minus 2. All right? But that's a composition where we take one function, whatever it is, and we plug it into another function. That's all a composition is. So we have another example here. I have f of x equals x squared plus 1. And g of x equals x plus 2. As we see, then f of g of x. And for me, whenever I see it with the little open circle, I'm always going to rewrite it because that just looks easier to me. It makes more sense. But f of g, so that'd be f of x plus 2. So then x plus 2 just gets replaced into x. That used to be f of x. Used to be x squared plus 1, but instead of x squared plus 1, we now have x plus 2 squared plus 1. So problem A, or problem 1, part A. We have two functions, g and f. So I have g of f of x. So again, I like to rewrite it, g of f of x. Now remember, please make sure you're saying, when you read it out, you say g of f This is not g times x, f. We are not multiplying things. We're not distributing things. We're plugging in. This is function operations, function notation. All right. Ellie, what is my function f? What do they give us? Squared plus 5x. So x squared plus 5x is going to be plugged into g. So whatever my f is now being plugged in to where I see x in my function g. G was x minus 4. So instead of x minus 4, what am I now going to have? Minus 4, right? So wherever I saw x and g, I now replaced it. Now this doesn't have anything to distribute or anything like that, so I can just write that as x squared plus 5x minus 4. That would be my answer for part A. All right, I want you guys to try part B. We're doing f of g of x this time. All right, let's go ahead and check it. B, f of g of x. All right, Jathan, what would I be doing this time? Now remember, that's not times, it's of, f of, okay? And how would that look? So we'd have x minus 4 squared, right? Because we take our g and we're plugging it in. And then plus what? 5 times. Yeah, I also have to do it there as well. So we have to remember that for this one, I have to plug it into everywhere I see an x. So we have two positions where we have x. So g gets plugged into both. So into the x squared and into the 5x. So f of x minus 4 would be this here. Now this we can go ahead and simplify. So that would be x squared minus 8x plus 16, I believe. I can also distribute the 5, so that'd be 5x minus 20. So I get x squared minus 3x minus 4. Okay, and that would be the final result for that one. All right, so my question is then, part A and part B, are they the same result? No, we did not. The b value is different, right? We have a plus 5x in A and a minus 3x in B. So no, these are not equal. They are not equal. All right, I want you to try problem 2, both A, B, and C. You have some examples there. I want you to try out problem 2, please. All right, g of h of x. Isabel, help me out with part A, please. Okay. Very good. So we plug in our h into g, and that should be the format that we have. Now we can simplify by multiplying our x plus 2 squared. Now I saw a lot of people try to write that as x squared plus 4. That is not x squared plus 4. You have to use your box and multiply through if that's what you're going to be doing. So that is equal to x squared plus 4x plus 4 plus 4 square root of x plus 2. And that's actually as far as we can take it. There's nothing else that we can do to simplify. Please do not add those 4's together. Does not equal 8 square root of x plus 2. That 4 is attached to the square root. It cannot combine with anything else. So everybody have that? We're good? Okay, part B. Damien, help me with part B. What is function h? What is h of x? So then instead of x, what are we putting? There we go, right? So x squared plus 4 rad x plus 2. Is there anything to distribute, multiply, or square, or anything like that? Can we simplify it is my question. No. So that's just x squared plus 4 square root of x, but now plus 2. All right, that is A and B. Now the hardest question of all, are those equal? No. All right, do problem 3, please. All right, we are doing f of g of x. Let's see, Aaron, what is g of x? Okay, and so we are plugging that into f. What would that look like? Plus 4, right? So all of g got plugged in to x. Now we can simplify that. Nothing complicated. Negative 6x plus 10 plus 4. And as I saw in a lot of your guys' papers, final result of negative 6x plus 14. All right, any questions on that? So let's look at this problem. Problem number 4. What is different about our compositions now on this problem than we were doing on the previous page? There's an x value, right? It's not just g of x or f of x. We actually have a value. So, when we have problems like this, I always like to work myself from inside to the outside. Meaning, and I'll go ahead and show it with f of g of 2. So what I like to do, I write it down, f of g of 2, and I start with the inside. So in a sense, I'm like I ignore the f part. Do we know how to do g of 2? What does that tell us to do? Just plug in 2 into g. But now I am going to be doing that inside function f. So I'm going to have f of, and I'm just going to plug 2 into g. So I start from the inside, working out. So that would be 3 of 2 minus 2. Well, what is 3 times 2 minus 2? 6 minus 2, which is 4, right? So g of 2 equals 4. But now that's not my final answer. What do I now need to do with 4? Plug that into f. So I'm working from the inside out. I did g of 2. I got what g of 2 is. Now I'm plugging that result into f. And so then that one would be 4 cubed plus 3 times 4 squared, which if I was to simplify all that out, I'd get 112. Now that's the way I usually like to do it. I like to keep it all organized within the function notation. But there are some people that they say, okay, f of g of 2. They don't like doing it within there. It gets confusing. So they say, okay, I know I need to know what g of 2 is. So they bring g of 2 kind of out, and they calculate that first. And they say, okay, g of 2, I know what to do with that. That's 3 times 2 minus 2, which equals 4. All right, now taking that value f of g of 2, I now know as f of 4, which that would just be this here. Okay? It's the same thing, just some people like to take that g of 2 out and calculate that first and then put the result back in. But it is the same thing. I like to organize it all within the same thing, but some people like to bring it out. Either way, doesn't matter. So what I want you guys to do now is flip it. We did f of g of 2. I want you to now do g of f of 2. Whichever way makes easier sense to you, go ahead and find that value, please. Right. Jacob, help me out with this one. G of f of 2. So what we got, guys? 58? All right, question, final question. Are they equal? The two values that we got? No, they are not equal. So f of g of 2 does not equal g of f of 2. Those are not equal. We're going to go ahead and do problem 5 together, and then we'll see if we have time for problem 5. We have find f of g of x for f of x equals square root of x, g of x equals x minus 1, and then if possible find f of g of 2 and f of g of 0. So we are not flipping this time, we're finding f of g at two distinct values. So this is actually another way problem 4 could have been done. Problem 4 could have been done where you find the composition function first, meaning I find f of g of x first, and once I have that function, I can then plug it in. Reason why I didn't do that on problem 4 is because I would have had to find two composition functions, f of g and g of f. I had two different ways of going. This is why I actually, if I'm doing it at a value, I kind of like doing it the way we did in problem 4. But in problem 5, we can find the composition function first and then plug in our values. So f of g, what is g of x, ladies and gentlemen? What do they give us for g of x in problem 5? All right, so what is our composition? Where does x minus 1 go? Into the square root, right? So that's going to be square root of x minus 1. So that's the function composition. So now that I know that, I can go ahead and find f of g of 2 fairly easily by just plugging 2 into that function. So as I was saying, if we already know what f of g is, if we found that, I can then, when I do f of g of 2, I don't have to do that whole process we did on the last one. I can go straight to my function 2 minus 1. What is 2 minus 1, ladies and gentlemen? So square root of 1 is equal to 1. So we have a value there. Let's go ahead and do the next one, f of g of 0. Again, I already know what f of g is. I have that function. So I can just plug in 0. What is 0 minus 1? Can I do the square root of negative 1 and get a real number? No, this is our imaginary complex numbers. So this has no real solution. So this is why it actually set up here, if possible. If possible, find them, right? If I was to plug in 0 into both g and f, g of 0 is negative 1. F of 0 is 0. I can plug in 0 to both of them, but I cannot plug 0 into the composition. All right, I want you guys to go ahead and do problem 6. You're going to be finding g of f when x equals 0, 1, 2, and 3. Does everybody have problem 5? Okay, so problem 6. This means you're going to find g of f of 0. Then you're going to find g of f of 1, g of f of 2, and so forth. Why don't we start with just 0 and 1? Let's get those ones done. So what is g of f of 0? G of f of 1. If you finish those, you can try the other ones.